So hello everyone. Today we're going to talk about R graphics. We have data visualization, so we're going to do some visualizations in R, right? So we start with plotting a dot, and then we'll plot a few dots together. So let's start the work in R. So we say we'll start with one dot. So we say plot 1, 3, right? I'm saying comma, not colon. So if I say plot 1, 3, a graph is created on the right side in the plot, and there is only one dot. Okay. If I say plot combination of bracket 1, 8, so 1, 8 is one dot, isn't it? 1, 8 is one dot. Then outside the bracket comma and C 3, 10. So I've given it 2 dots. So a plot with 2 dots is created, right? I can also have more dots. So I can say plot C combination of 1, 2, 3, 4, 5, and then comma combination of 3, 7, 8, 9, 12. So another, let's see what happens. So I have a few dots. Okay. So this is a combination of 1, 3. See, this dot is 1, 3. This dot is 2, 7. So 2 from here, and says, so x-axis is this and y-axis is this. So the last dot is 5, 12. X-axis is 5, y-axis is 12, right? So I can plot dots like these. So that means whatever before comma, when I say plot, before comma, I'm giving the x's, and after comma, I'm giving the values of y. So I can give few number of y's, or I can give only one. I can also plot like, I can say x is equal to C, a combination of 1, 2, 3, 4, 5, and I can say y is equal to a combination of 3, 7, 8, 9, 12, and then run it, and then I say plot x, y. That also will create, because I didn't run x and y. See, I didn't run, so it gave me an error because it didn't know what is x, what is y. So now I can plot x and y. This is the same thing what I have done earlier. Okay. Now, like we discussed earlier, I can plot a whole line by saying plot 1 to 10. So I can plot a line like this. Okay. I can also say plot, these are dots. I can plot a line. I can say plot 1 to 10 numbers, comma, type. Type is equal to, see, type comes up here, and I say equal to, and say L. Okay. How do I know type is equal to L? Because I can find out, I can say plot, question mark plot, and here it gives me, I can say 2 question marks, and it gives me information about these plots. Okay, I can find out all these help page. It helps me to find out what do I give here. Okay, plotting x and y, generic plotting, default plotting. So see here, arguments, type here. These are the types. If I say P, it will give me points. If I say L, it will give me lines. If I say B, let's say B here. I say B here. It gives me both, right? And what else is there? If I say C, for the lines part alone of B. O for both overplotted. H for histogram. S for stair steps. Let's see if I say S here, what happens? Like this. Okay? So you can find out from help the type. Now, this is my main plot, but I want to give it heading and I want to give x-axis label, y-axis label. So how do I do that? I say plot 1 to 10 numbers. Then I say main. Main is equal to my graph. Main is equal to my graph. So it will give me main is equal to my graph. So main comes in my graph. I can also say, I can also add X label. So I say XLAB. X lab is equal to, I can say the X axis, whatever I want to name it as, right? And comma Y lab is equal to Y axis, the Y axis, okay? And right, so now I can also say comma col, which is color. Col is equal to, I can say red, right? So let me say is equal to red. Let's see what it does. Yeah. So it gives me a plot. It gives me the x-axis. See, I wrote the wrong spelling. So the wrong spelling is here also. So I do this and I run again axis. So the y-axis, the x-axis, the name of my chart, and the color. So I can do all this. Okay. Then, right. So I can also use, let's see, I can also say there is a CEX command. So let's say I want to use the CEX command. Right, so I say plot from 1 to 10, comma, PCH is equal to 25, comma, CEX is equal to 2. What happens? I get these boxes, these triangles, right? So, right. So use PCH with a value from 0 to 25 to change the point shape format. I'm changing the point shape format. Okay. And CX is equal to number to change the size of the point. It's the size of the point. So 2 is the highest, 100%. 0.5, 1 is default. 0.5 is less than 1 and 50% or smaller. And 2 is 100%. Right? So I can change the size. So if I say CX is equal to 1 and then do it, see it becomes smaller. Right? So I can change the size also of the point. Is it making sense? Right. So here also in the PPT we have all these points, and so the value of PCH parameter ranges from 0 to 25. So if you give whatever shape you want, you can give the number and that shape will be given to you. And if you want to know it here, you can always use this question mark and plot to figure it out. Right? Then line styles. So line style here again, we have line LWD is equal to 5, LWD is equal to 5, and LTY is equal to 3. What is LTY? For example, LTY is equal to 3 will display a dotted line instead of a solid line. So here we have displays a dotted line, a dot dash line, a long dash line, 2 dash line, solid line, whatever you want, you can give the dots. Okay. Then here also multiple lines. So I can say plot line 1, this type is equal to L, color is equal to blue, and line 2 already I have given the dots, type is equal to L, color is equal to red. So I'll have 2 lines here. Now scatter plots. Let's make a scatter plot. How do I make a scatter plot? This is a scatter plot, the ones we made earlier. So X and Y, some values, and you plot them, gives you a scatter plot. So whatever we made here earlier, how do I see the previous plots? These are scatter plots that we had made. This is a scatter plot. When do we make a scatter plot? When there are two numerical values. X is also numerical, Y is also numerical. We make a scatter plot. Then I can add, like we said, main observation, X lab is equal to car age, Y lab is equal to car speed. And then I can have two types of colors, two different cars. So I can have day 1, the age and speed of 12 cars, day 2, the age and speed of 15 cars, right? So I'm saying plot X1, comma Y1, main is equal to observation of cars, X lab is equal to car age, Y lab is equal to car speed, color is equal to red, CEX is equal to 2. And then plot X2, Y2 also in the same plot, where color is equal to blue. So blue is the one on the second day and red is the one on the first day. So in the same plot, I have plotted both, right? So we come to bar charts. Let's plot bar charts now. We'll do it in R. Bars are very popular and we use it very often. So we can have, say, X is equal to C A. When do we plot bars? When there is one categorical variable and one numerical variable. So that's what we're going to create here. One categorical variable, B. So X becomes my categorical variable. There are 4 categories and Y becomes my numerical variables. So C is equal to 2, 4, 6, 8. So now I have 2 variables. I have saved them, X and Y. I've run them. So now I say bar plot Y, comma, names dot arg is equal to X. So here is my bar plot. The names of the categories are A, B, C, D, and these are the bars, right? And in the same way, I can say color. So COL is equal to red, and it becomes red, right? And I can also look at the density. So I can say comma density is equal to 10. So how do I know density has to be 10? Again, I say question mark bar plot. When I say this and run this, it gives me all these descriptions. So all these values I can fulfill, and all these are called parameters of my function. These are, so I can give them legend, space, border, subtext, while limit of y, limit of x limit goes from what value to what value, and what would be the syntax. Here it is given, and there would be an example at this. So y lab is label, x lim is limits. Limits means whether it should go from 0 to 1, 2 to 4, whatever is the limit you want, and there is always an example at the end on how to write it. Some or the other example is given. So see here, this is an example given. This is an example. Let's see if we can run this. Let's see if this works. Control C I've done. Now I go here, Control V, and I go here and then run, right? There it is. Yeah. So it's giving me a lot of information. Yeah. So you can explore this further later on. Yeah. I can also change the width. So I can say that color is equal to red, or let's take this out and say width is equal to, so width is equal to C 1, 2, 3, 4. So let's see what happens. See, I can increase the width of each of the bars depending on what I want to do, right? So we save this as a file, and we can say save it, and wherever we want to save it. So we go to down the documents, we go to our file and say either we can save it in data visualization or this. So we can say our visualizations, and today's date is 29th. Okay, and save. So my file is saved, right? I can close this whenever I want. Let's go back to our PPT and see what's remaining there. So we've done this, we've done this. Now, why do we do visualization? Because visualization helps us in represent data in the form of graphs, charts, plots, etc. A story is conveyed through visuals, and patterns, trends, and anomalies in data can be found out. So if you put a scatter plot and most of the dots are together, but there is a dot at the far end, that means that is an outlier or anomaly in data. So if you look at this data, an introduction to airline reporting carrier on time performance data set, this data is not making much sense. But if I present it like this in some graph, then it makes more sense. So that the count of the these are almost the same for each month. There is a variation here. So this graph versus this graph, I can see that this graph is not showing so much variation for each month, but this graph is showing a lot of variation. So visual representation helps me a lot, especially when there is a lot of data. When there are few data, 8, 10, 20, 30, still I can manage, look at the data and figure out. But when there's a huge amount of data, then visualization really helps. So what are the chart types? So for comparison, we use bars, grouped bars, bubble chart, radar chart, horizontal bar chart. These are for comparison. For trends over time, we can use line, area, stream, histogram, or box plot. We'll discuss what is a box plot. For correlation, when do we do correlation? We do correlation when both the variables are numerical. When X is also numerical and Y is also numerical. For example, my height and my weight, both are numerical. So we just plotted two numerical variables in our plot, right? So we gave it X and we gave it Y. So that gives me a scatter plot. So correlation, scatter plot, or also heat map, right? For part of the whole, we use pie charts or stacked bars or even tree maps. For relationship, we use T diagrams, and for maps is also another type of graphs we use. So these are broadly the graphs that we use. We should know when to use. Comparison usually happens when we have one categorical variable and one numerical variable. So we want to know that for each category, what is the numerical value, isn't it? We just we did. So we have comparison here. So comparison, for comparison, bars is there. So there's a very, very popular package in in R called ggplot2. We'll have an introduction to it in our next class. But that ggplot2 helps us to do bar chart, histogram, pie chart, scatter plot, line plot, and box plot. Then there is also another package, leaflet, that helps us do maps. So we will look at ggplot, just the introduction of ggplot. So data visualization helps us to see trends, patterns, and anomalies that are not obvious when looking at raw data. There are 6 main categories of charts, including comparison charts, trend charts, part 2 whole, correlation, relationship and connection, and maps. And the R package for visualization are ggplot2 and leaflet. So we'll start with ggplot2 in our next class.